Welcome, I'm Tim Sever, and today we're going to look at an example of where a function is not differentiable. In fact, the function will be f of x equal the absolute value of x, and we're going to consider the x value of 0. So let's briefly look at the graph so we can see what's happening. And I think we all know what the absolute value of x looks like. Just demonstrating it here. And we see there's a sharp corner at 0. And it's this sharp corner that will cause the function not to be differentiable. If you think about it, on the right-hand side of 0, we have a tangent line whose slope will be 1. This will come out in the limit. And on the left-hand side of 0, you have a slope of the tangent line is -1. Those are two different limiting values for the slopes. So the derivative won't exist there, which the derivative being the limiting value of the secant lines, which is the tangent line, doesn't exist there. Okay, let's look at it. Now again, we're going to use the definition. So, what is f prime of x? If it exists, it's defined to be, and in this case, what is our x value? What's our x value on the graph? 0. So rather than doing the derivative of f at x, I want to look at the derivative of f at 0. So this is the limit as h goes to 0 of f of 0 plus h minus f of 0. Okay, over h. And let's see what this limit becomes. All right, first thing we want to do is do the simple arithmetic. 0 plus h is h. So f of h, when f is the absolute value of x, is just the absolute value of h. And the absolute value of 0 is 0. Okay, so now we get our well-known limit from the previous chapter. This limit doesn't exist. Why? Well, let's just do a quick drill down. Let's review. Let's do a just-in-time review of this concept. Remember, the full limit exists if and only if the limit from the left is equal to the limit from the right. So what we could do is investigate those two limits, which is what I'll do separately. All right, let's see. Now, I need to do these two limits separately. So when h goes to 0 from the left, that means h is less than 0. And when h is less than 0, we know the absolute value of h is minus h. Now we can use functions that agree at all but one point, canceling these two h's, getting a constant. So we get the limit. I can write this out one more step, and this, of course, still from the left is -1, and then, of course, this is -1. So the limit from the left at 0 is -1, and what that says is the slope of the tangent line to the left of 0 is -1. Now, in this case, it's actually constant for all values, but we're only really considering the x value of 0 here. So let's do the limit from the right. Now, when when h is to the right of 0, h is positive, so the absolute value of h is, of course, h. This cancels, again, using our theorem functions that agree at all but one point. So this is just 1. Well, let me write these kind of somewhere. All right, so here we have -1 from the left, we have 1 from the right. These, of course, are non-equal. So what do we know? Well, we know the full limit doesn't exist. We conclude from here that the limit as h goes to 0 of the function at hand, which is the absolute value of h over h, doesn't exist. In fact, it has a removable discontinuity there, which we can see in this graph. Now remember, we're not graphing the original function. I'm graphing this function, the absolute value of h over h. So it has an open circle here at 1, open circle here, and this is the graph, I'll call it G. And of course, you have a non-removable discontinuity here. So g of 0 is undefined. Jump discontinuity, so of course the limit here doesn't exist. Okay, so what have we shown? We've shown, in terms of doing the review, this limit doesn't exist. Now let's go back to the problem at hand. All right, so the f prime of 0, does it exist? Is it no. So f prime of 0 is undefined. So what we say, f does not have a derivative there. F is not differentiable. At x equals 0. I.e., another way to say that is f prime of 0 is undefined. Sometimes we write D and E for undefined here. Okay, so the presence of a sharp corner means that the function would not have a derivative there. There is no slope of the tangent line at that point because there is no tangent line. Thank you.